So in this part of the video, we are going to see how set theory can be used to solve some real life problems. For example, you look at this problem. A collection of 60 people has been surveyed, and out of them, 25 of them read newspaper A. So it's about them reading some newspapers. Okay, 26 read newspaper B, 26 read newspaper C, and some other similar information is given. Now from these things we have to find the number of people that read at least one newspaper and also the number of people that read exactly one newspaper. So let us start the solution, and there we will see why set theory is used in this type of problems, so that when you look at problems like this, you will immediately know that set theory has to be used. Okay, so we start by defining some sets. Let SA, SB, SP be the sets of people out of the 60 people surveyed that read newspapers A, B, C respectively. Okay, so we start off by defining these three sets. SA is the set of those people out of these 60 people, okay, not all the people in the world. Out of these 60 people, SA is the set of those people who read newspaper A. SB is the set of those people who read newspaper B, and similarly SC. So that's what we have written. Also, let S be the set of the 60 people surveyed. Okay, we consider the set of all the people who have been surveyed. Okay, that collection also we are naming, and that we are considering that as a set. Right now, given that these sets have been defined, now what do we know from here? What is given to us? Okay, I can wrap this part up and I can write like this. So that means I am continuing from here. It is given that, okay, so SA is the set of those people who read newspaper A, and what is given to us, I wrapped that number now. 25 people read newspaper A out of the 60 people. That means the cardinality of A is 25. This is given to us. Similarly, SB is the set of people reading newspaper B. So that means the cardinality of SB is 26, and which is also the cardinality of SC. Okay. Now, what else is given? 9 people read both newspapers A and C. Now, reading both newspapers A and C means that these are the people who are common to these two sets, SA and SC. So that's why SA intersection SC This is given to us and it is 9. 11 people read both A and B. So that means SA intersection SB is 11. And 8 people read both B and C. So cardinality of SB intersection SC is 8. Also, there are 3 people who read all the 3 newspapers. That means SA intersection SB intersection SC is equal to 3. Now, what are we asked to do? What are we asked to find? Find the number of people that read at least one newspaper. Okay, so now with the help of a Venn diagram, we will try to understand what is asked of us. Since there are 3 sets, we have already seen while discussing the operation symmetric difference of sets, or more specifically while discussing this thing, that symmetric difference of 3 sets is associative. Or for example, what I'm trying to say is that the operation symmetric difference is associative. Remember, we have not proved this. We have only mentioned that it is quite lengthy, but we drew the Venn diagram for this, and there we saw how 3 sets have to be drawn. So we are going to do a similar thing here, just to see what these find the number of people that read at least one newspaper. So the set of people that read at least one newspaper, that also will be there somewhere, no? So that's what we want to draw here. So this is, suppose SA, this is SB, and this is SC. SA, SB, SC. But at the same time, besides these sets, we also have surveyed 60 people. So that also has been considered as a set S. So you can see that in this case, these 60 people constitute our universal set, because they are the only things we are considering here. We are concerned about them. So in this, I could have named it U, but I have named it S anyways. It does not really matter. So this is our universal set. S has 60. Okay, that also you can write, no? Cardinality of S is 60. So out of these 60 people, this whole set, this rectangular region representing that set, SA has 25 people. SB has 26, SC has 26. And this part, which is common between SA and SB, that has 11 people. The part common between SA and SC, this part, that has 9 people, and the one between SB and SC, this part, it has 8 people. And the innermost region, the region that is common to the 3 of them, that has 3 people. So we are asked to find the number of people that read at least one newspaper, which means someone who reads at least one newspaper can either be here or here or here or here, in these places. Okay, if the person reading is here, then that person reads only newspaper A. If he is here, then he reads newspapers A and B but not C. If he is here, then he reads only B. If he is here, then reads only C, and similarly. Okay, so we are required to find note that someone can be here also who reads none of these three newspapers. That person may read some other newspaper or may read something else or may not read anything at all. Okay, so that option is also there. That's why it is given that a survey of 60 people has been done. So that number 60 is important. It is the number of all the people available. Okay, so we are required to find people who read at least one newspaper. That means these people are not accounted for. So that means we have to find the number of people here. So we need to find this. SC, this the cardinality of this union, and exactly one newspaper. Exactly one newspaper means, for example, if someone reads exactly A and nothing else, then he will be here. Okay, if someone reads exactly B, then he will be here. And if someone reading exactly C will be here. So we are required to also find the number of such people. So that means and cardinality of SA minus only this part. Okay, only this part means SA minus B, SB union SC. Minus SB union SC. But that is just the number of people reading newspaper A. But we also, along with this, need the number of people reading just newspaper B. Note that this is union, not intersection. Union, number of people reading newspaper C, only C. So this second one is naturally much harder to find than the first one. So for the first one we have ready-made formula and we have all what we need to find that one, to calculate that one. So let us start. We have, if you recall, first of all we know how to find the cardinality of the union of two sets. Then using that we found out a formula for finding the cardinality of a union of three sets. So that's what we are going to use here because we have three sets. So cardinality of SA union SB union SC is equal to, if you remember, you first of all have to add the cardinalities of the individual sets. So that's what we do first. Then we have to subtract the cardinalities of intersections of two sets from these three, all possible such intersections. So we have to subtract the cardinality of SA intersection SB, SB intersection SC, SC intersection SA, or A intersection C, since intersection is commutative. And then we have to add the cardinality of the set that is the intersection of all the sets. And we have these things available to us. So this is equal to 25 plus 26 plus 26 minus 9 minus 8 minus 11 plus 3. So this equals 52. So there are 52 people out of 60 people who read at least one newspaper. Remember that among these people, there will also be people who read all the three, but still they are reading at least one. So that's what we have found in the first part. Is this calculation correct? Let me check once more. Okay, my calculations usually are wrong. Although I can understand the theoretical concepts, but when it comes to calculation, which some of you may find so easy that you can do them mentally also, but I have this, what can I say? Sometimes I make mistakes with simple calculations. Okay, so let me check once more. Okay. Yes. Okay, so this is all right. Now we have to find the cardinality of this, right? So you can see, or you can see from here. I mean, if I redraw the diagram in a simple manner, this is the first set, right? And the first set is this. The second set is this. The third set is this. So these sets are mutually disjoint. Okay. No two of them or no three of them have any elements in common. So that means the number of elements in their union will just simply be the sum of the number of elements in each of them. Because, for example, if you have three bags, okay, three separate bags, there are two objects here, three objects here, and five objects here. So together, if you mix them up, then the number of objects will be 10, 2 plus 3 plus 5. So that's how, because there is no common element, okay, that condition has to be true. Unlike this one, where there may have been, I mean, there were some common elements. That's why we had to subtract some, add some, so the formula is complicated. But we can simplify this one. So next, by writing like this, cardinality of, let us first of all write the set SA minus SB union SC union SB minus SA union SC union SC minus SA union SB. This is actually equal to cardinality of SA minus SB union SC. plus cardinality of SB minus SA union SC plus cardinality of SC minus SA union SB. That's it. Because they don't have any elements common, so we are not counting while we are adding. We are not counting any element more than once. Okay. So that's why there is nothing else in this formula. It's like SASB. You see, in this formula, if we had SASB and SC mutually disjoint, right? No two of them have any elements common. If that was the case, then these intersections would be empty, so that these parts which are being subtracted and then this one added, they will become zero. So the formula is just this is equal to these three terms. Okay, that's what we have here. Okay, had there been some mutual intersections, then this will go on just like this one. But luckily here we have the mutually disjoint, so we have been able to write the formula like this. Now each one of them we have to find separately. Now here again we will take the help of our familiar formula, the one of finding the cardinality of union, but for two sets. You see, because we need this SB union SC, right? Now, so let me go systematically. First we find this one. This is equal to minus this. So SA is 25, SB is 26, and A intersection B is 11. So this gives me 40. Right. Now SA minus SB union SC. So that means we have SA here and SB union SC. This part we know. Okay. This part we know, okay. But we cannot subtract this from the cardinality of SA, because then we will be subtracting some extra elements. So what has to be done here? Exactly one element. Instead of trying to find it directly like this, we can also try to do something like this. That means I am trying to find the cardinality of this one, and this one taken together. How can I describe this set in a slightly different manner so that I can carry out the calculation nicely? Also, note one more thing. You see, trying to proceed in a direct manner has led us to a difficult situation. Why? Because if I try to calculate this, that means, okay, this is SC. Suppose this is SA and SP. I have found out how many elements there are in SA union SP. But from the cardinality of SC, which is 26, I cannot subtract all these elements because I have to subtract only this part. Otherwise, if I am subtracting all the 40 elements, you see what happens? 26 minus 40, you get a negative answer which is meaningless. Actually, that is wrong because negative number of elements does not mean anything. Also, that should not be done because we cannot subtract these elements which are not there in SC. We have to subtract only those elements which are there in SC but not in SA or SP. Okay, so that way we cannot proceed like this. So instead we have to formulate a different strategy. The set is same, we have to find its cardinality. So what can we do actually? Okay, I know this set SA intersection SB, this set I know. I also know this set SA intersection SC, and I also know this set SB intersection SC. Okay. So if I find the cardinality of this union of these three sets, this one, and this one, then I can subtract this cardinality from this cardinality, the one we have found, which is oh, I forgot what the hell. Well, I needed an answer. 25, 26. What was it? Can I remember? No, I can't remember. 26, 3. 80 minus what was it? 52, yes. So there are 52 elements in the union, this one. Okay, out of those 52 elements, if I subtract this number, then I will get the cardinality of this part. Okay, so that is another way, and that is, I think, that will not lead me to any difficulty because you see, unlike this situation, here the elements that we are subtracting are inside the set from which we are subtracting. We are subtracting from this one, right? And this set with the lines, this set is a subset of this set. So whatever we are subtracting, those elements are already here. So we will get the correct answer. So this part is not necessary. And 52, right? We have to remember. This is 52. Okay, now, so we need the cardinality of this set. So we find it. Now these sets are already intersections. SA intersection SP. Okay, union SB intersection SC. Union SC intersection SA. Now we can apply the formula just like this one for union of three sets. but that will be quite lengthy. Instead, can we use the set theoretic identities that we already have studied previously, for example, distributive law, associativity, things like that. If you look at this carefully, you can write, for example, but if I simplify this, will that help me in any way? That I have to first of all find out. You can clearly see this is this part. On this part, I can use the distributive law. Instead of this union, I can write SB intersection SA union SC. This I can write. But then we have union with this one. I don't think it will help me much. So let me just use the big formulas straight away. So this is equal to cardinality. First of all, we have to add the cardinalities of the individual sets. Minus. Then we have to take intersections of any two of them. So SA intersection SB intersection SP intersection SC. Oh, I thought this would be much more difficult than the other way, but this will become simplified. Okay, you will realize why. SB intersection SC intersection SC intersection SA minus SC intersection SA intersection SA intersection SB plus intersection of these three sets. Okay, so I write it here. SA intersection SB intersection SB intersection SC intersection SC intersection SA. Okay, this is what we have found so far. Now, this is equal to, if I continue from here, these numbers are already available to us. 11, right? 11 plus 9, or if I write this one first, plus 8 plus 9. So these are these three numbers. Minus, now if you look at this, it's just SA intersection SB intersection SB intersection SC. It's just like this. SA SB SC. So SA intersection SB is this set, and SB intersection SC is this set. So their common part is this one, which is nothing but this intersection. Okay. Similarly, if you look at these ones, you will also see that here also you have this same set. So although these things look different, but they are actually the same thing. In fact, this one also is the same thing, SA intersection SB intersection SC, because it's the intersection of these three sets. Okay, so that means I have minus intersection SC minus again that same thing minus again that same thing. That means 3 times 3 into this plus Again I have this one is also okay. So from here I am what am I getting? 28 minus 3 times something plus that thing is equal to minus 2 times. Now this is available to us 3. So this is 28 minus 6. So 22. That means that region we have here, this region inside the union of inside this union, this region has 22 people. Okay, and this one has 52. So if I am subtracting this one, then I am subtracting this portion from the whole union, then I get what I require. Okay, so hence the number of people that read exactly one newspaper is equal to 52 minus 22. So this is 30.